In this video, we are going to be talking about functions involving base e. So the first two that we're going to graph are f of x equals e to the x, and then we're also going to graph g of x equals e to the negative x, and then just compare what happens with them and find the domain and range of each of those. So first thing I have to do is pick some values. Because e is an irrational number, so it's an irrational base, there's almost no value here that I could put and get whole numbers. There is one, but after that these are all going to be decimals. There's no way to really get nice values. So I'm just going to pick some x values to plug in. Let's do -1, 0, 1, and 2, and just see what happens with those. And if we need to pick more, we can. So when I plug in first f of -1, I get e to the -1 power, which is approximately, let's see, if I take 1, make it negative, e to that power is 0. I'm just going to round to the nearest tenth because I really can't graph any more accurate than that by hand. So 0.4. Now let's do 0. So I have e to the 0 power. This is the only one that's going to be nice. Anything to the 0 power is 1. That's a nice whole number. Now let's plug in f of 1. E to the first power. Well, we know e itself is 2.181 blah 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 blah. We're just going to round it again to the nearest tenth, so 2.7. And then f of 2, e squared, is 7.4 approximately. I should be using approximately here. And let's just do one more. F of 3, so e to the third power, is approximately 20.1. So that is now officially off our graph. So let's plot these. -1.4, so pretty close here to the x-axis. 0, 1, which was our nice point. 1, 2.7. So about a third of the, or 3/4 of the way up there. And 2, 7.4. And then 3 was off our graph. Now this is an exponential function. It's going to get close to that x-axis, but never crossing it because, sorry, this is by hand on a computer. It's not amazing. It doesn't matter what exponent I put in here. I could put in -1,000,000, but all that's going to do is turn this into a fraction. So it's just going to be closer and closer and closer to that x-axis, but not crossing it. So if you wanted to extend this out, just make sure it does not go below that x-axis. Alright, now let's do g of x equals e to the negative x and see what happens. I'm going to pick a different color here. Let's do orange. Alright, I'm going to go ahead and test out some values to see what's going to happen here. Let's just go ahead and put 0 in the middle. Obviously, g of 0, anything to the 0 power, because there's no -0, it's the same thing as just e to the 0, is 1. Now let's test some values around that. If I picked +1, now when I plug that in, what's going to happen is it's going to make it negative, right? Because I already had that -x. And we already know from our last one, e to the -1 is 0.4 approximately. And let's go ahead and do, let's plug in a -1. So negative is going to make a +1. And we know e to the first power is 2.7. So when I did -1, I got 0.4. When I did, or sorry, backwards. When I did -1, we got the 2.7. When we did +1, we got 0.4, or 0.4. Right? So it's kind of flip-flopping our values here. Right? Instead of negative giving me 0.4, -1 gave me 2.7. +1, instead of getting 2.7, gave me 0.4. It's because of this negative exponent here, it's changing our signs, and negative exponents take the reciprocal. So I know that if I keep moving down with +2, then that's going to end up a -2 when I plug it in. It's going to make a smaller value than that. I really can't graph more accurate than 0.4. So I'm going to go ahead and go in the negative direction to -2. So g of -2, again, a negative times a negative is going to make a positive, and e squared was 7.4. Oops. And I know that if I plug in -3, I'm going to get 20.1, which is off my graph. So I'm just going to go ahead and plot these values here. So let's see, I have 1.4, 0, 1, -1, 2.7, and -2 was at 7.4. And we see this is going to be the same graph, but now it's a mirror image across the y-axis. So when we talk about the domain for each of these, remember domain is the inputs, the x values. It's how far left and right we can go. So the domain for both of these will be -infinity to infinity. They will go left and right forever. The range for these, same as our exponentials. So if this base was any other number, if it was 4 or 3 or 17, we talked about the exponential functions. That range was all positive values. So it's going to get close to 0 but never touch 0 and go up forever. Range is the outputs. How far up and down will it go? So again, this was an exponential, same domain and range as our general exponentials, even though the base is e. Why don't you go ahead and try to graph the next example? Alright, in this example we have f of x equals e to the -x power plus 1. And then we have to identify the domain and range of that. So I'm going to plug in some x values, get out the y values, because this is an exponential function. The base is e. E is 2.7 approximately. So and I have a negative here. So just like we did in this last example, we know we need to plug in negatives because it's going to end up a negative makes a positive. So I'm going to plug in -2, -1, 0, and 1 to see what happens. F of -2, we're replacing x with -2, and that plus 1 is not part of the exponent. A negative makes that positive, and e squared, we've learned this from past examples, was 7.4. But then I have to add 1, and I get 8.4. And these are all approximately. Alright, so 8.4. Then I'm going to do f of -1. So again, that negative will make it positive 1 plus 1. E to the first power is about 2.7 plus 1 will make it 3.7. F to the 0 power, e to the 0 power is just 1, and 1 plus 1 is 2. F of 1 is e to the -1 plus 1, and e to the -1, we did that also before, and we got 0.4 or 4/10 approximately, plus 1 would make it 1.4. And because that's not too small, I'm going to go ahead and do another one. So e to the -2 power plus 1. Let's go ahead and plug that in. So -2, take it to the e power. I'm going to round it to the 10th, so approximately 1/10 plus 1 would be 1.1. So we can see that each time this e power, so if I plugged in 3 or 4 or 5, I'm still going to take the reciprocal of it, and this first value, the e to that power, is going to get smaller and smaller and smaller, but then I'm constantly going to be adding 1. So let's graph these. I had -2, 8.4, and -1, 3.7, 0, 2, 1, 1.4, and 2, 1.1. So this is going to come down, and again it's going to get closer and closer to that 1, but it doesn't appear that's going to cross it, because each time I'm going to be adding 1 to whatever this teeny tiny number is. I'm going to add 1. So the domain of this function is still going to go left and right forever, so I can put anything I want in for x. The range is how far up and down, and instead of getting close to the x-axis, it's getting close to the 1 value, this what we called k when we were talking about exponentials and how they shifted. It has shifted up 1. So it's going to get close to 1 but never touch it and go up forever. And there you go. So remember, e to the x power is the same thing as an exponential. It's just the base is a very specific number, that irrational value of e, but it will still have the same characteristics as any other exponential. It'll cross at 0, 1. It'll have a domain of -infinity to infinity and a range of 0 to infinity. And then these h and k values can shift it. If there's a value up with the x, it could shift it left and right. If there's a value that you're adding or subtracting to the whole thing, it's going to shift it up and down.